Whatever it is you're doing and wherever it is you are, I want you to do something of monumental importance for me right now. I want you to reach out and grab hold of something that's on your desk, your coffee table, your car, wherever you are, just around you somewhere. It doesn't matter what it is. Could be your cat. I've picked up this plant mister. I want you to pick it up, admire it, and then put it back in almost, but not quite, the same place. Alright, done that? Well done. You, insubstantial, ephemeral, beautiful you have just altered the entire course of the rest of life on Earth. Everything that ever interacts with that thing, from now until the day the Earth blinks out, will never quite do it in the same way as before you picked it up and fiddled with it. It's 1961 in the Massachusetts Institute of Technology in Cambridge, in America. A small team of academics are loading up a computer with some equations, 12 equations to be exact, 12 equations that are simulating the key movement of gas within Earth's atmosphere. The team is led by a man called Edward Lorenz. He's a mathematician and a meteorologist. He came up with the equations. Now, in 1961, coding up a computer was not straightforward. The computer that they used, an LGP-30, weighed nearly half a ton. It would be laughably primitive to us here in the rarefied year of 2025, but it was utterly state-of-the-art back then. What Lorenz and his team were doing were modelling the Earth's convection. They had basic equations that simulated how various things in the Earth's atmosphere interact with each other over and over again, and they just let it run. The point was to learn how to use computers to predict the weather. They would tweak one of those variables, like the equation that modelled the strength of the western wind, and they would see what effect that had on the weather within the model. Right, so one day, Lorenz wanted to rerun a weather prediction that he'd just done. He wanted to start at the middle of it rather than rerun the whole thing again, because that would take a lot of time back in 1961. And happily, the computer would print out the values it was generating as it went on. So all he had to do was find the printout, find the value for the middle of the run, type that in, and then he could pick up where he left off. So he goes through the printout, he finds the key number on the printout that corresponds to the right place in the run, happened to be 0.506. He types in 0.506 into the LGP-30, sets it off running, and goes to make coffee. An hour later, he returns. The computer has simulated 2 months of weather. Lorenz expected, of course, to see the same results as last time, but instead, the results, the weather, is wildly different. How can that happen? The numbers were the same. He can see that he hasn't entered them wrong, so it can't be that. There must be an error in the system somewhere, but just before he calls for technical support, for someone to come and bash it with a hammer, he realises what's happened. You see, the values inside the computer were being calculated to 6 decimal places, but the printout, to save space, only ran to 3 decimal places. So Lorenz had gone to the printout, got the right number, which was 0.506, and typed it in. But the real number, the accurate number, was actually 0.506127. A microscopic, tiny difference, but one that mathematically and literally changed the world.
I found that the new values at first repeated the old ones, but soon afterwards differed by 1 and then several units in the last decimal place, and then began to differ in the next to last place, and then in the place before that. In fact, the differences more or less steadily doubled in size every 4 days or so, until all resemblance with the original output disappeared somewhere in the second month.
See, if you take a tiny, tiny difference in one starting assumption, of a very complicated system. If you run a model that then simulates over and over and over again what happens when that tiny difference in number interacts with loads of other ones, you will get a totally different outcome. If you change one tiny thing, Lorenz discovered, and you change everything. Just like you, when you moved that thing a few minutes ago. Lorenz wrote this idea up and became famous for it. He came up originally with a metaphor of a seagull flapping its wings, which would eventually change the weather. His point, primarily, was that predicting the weather into the future is really, really hard because vastly complicated interactions, hugely sensitive to one tiny change somewhere, equals, in mathematical terms, chaos.
Yeah, it's down to what in physics we call the innate chaos of the atmosphere. And that sounds like we're being a bit hand-wavy and saying it's just a chaotic system. But that is actually the case. And this is sort of Edward Lorenz's famous butterfly effect, where it was suggested that a butterfly flapping its wings at the other side of the Atlantic could influence the weather here in the UK. And there is a certain amount of truth to that. Everything is interconnected.
That's my guest on this episode of Your Brain on Climate, Helen Roberts. Helen is a socio-meteorologist. I'll let her introduce herself and what the hell a socio-meteorologist is in a minute. But let me just quickly finish Lorenz's story first. See, 10 years later, a conference organiser looking for a snappy title for a talk that Lorenz was about to give about his seagull metaphor went rogue, and he changed the animal. Instead of a seagull flapping its wings, the organiser billed the talk as being about the flap of the wings of a butterfly. Much more poetic. And so was born a description of the innate chaos of the weather system and a metaphor for thinking about change that endures to this day. The butterfly effect. On this episode of Your Brain on Climate, we're going to learn all about predicting the weather and how people think about the weather. Predicting it, as Helen says, is hard. So hard, in fact, that it is an astounding testimony to humanity that we can even do it at all. Weather forecasts on demand are something we just completely take for granted these days, to the extent that some people get very miffed at weather presenters when they get news about the weather that they don't like or believe. Weather presenting used to be just about advising people whether to take a brolly or not. But as our climate changes, and with it, the weather too, meteorology finds itself on the front line of climate communications, and even, amazingly, the culture war. That means it's on the front line of climate psychology too, and that means we're interested in it. So how do you get across that the change in the weather is down to climate change? Do people really want to think about climate apocalypse every time they pick up the newspaper to see the forecast? And what can we learn from how to communicate risks that some people do not want to hear from some of the best risk communicators in the business, the weather people?
Your brain on climate.
Welcome to Your Brain on Climate, the show about human brains versus the climate crisis, and what we can learn about how to think about climate change from how we think about all sorts of other stuff. I'm Dave. It's a pleasure to have your company. And you've already met my guest on this episode, Helen Roberts.
So I'm Helen Roberts. I'm a socio-meteorologist, and that is all about working at the intersection of the physical and the social sciences, and I guess more specifically psychology and behavioural science for effective communication of weather forecasts and warnings.
Go on and bring that to life for me a little bit. What does a socio-meteorologist do in practice?
So my main area of focus at work is warnings, weather warnings, and that whole warning process. And actually my research takes me right the way through from observation, so what the weather is doing now, through the forecast process, including the human bit, so the human operational meteorologists, or weather forecasters, as we used to be called, to
You're not allowed to call them weather forecasters anymore.
Well, we changed our name officially, how long ago? About 10 years ago. So yeah, it's a bit more of a mouthful, and also really difficult to type, I always find.
Yes, I'm trying to write it now so I don't forget, and it's a lot of letters and I can't fit it.
It is a lot of letters, yeah. So operational meteorologists we are these days. And yeah, right the way through to the communication and beyond. So thinking particularly about users responding to warnings. And of course, we say it all the time, but a weather forecast, a weather warning has no intrinsic value unless people are making good decisions as a result of them. So that's what it's all about.
Now, before we get going, the usual housekeeping. This is a happily listener-supported, independent podcast, something it's increasingly hard to be given the economics of podcasting these days. Without your kind support, there is no show. So if you want to join the loyal lot, chipping in a few quid a month as a thank you, you can do so at patreon.com/yourbrainonclimate. You can email me at hello@yourbrainonclimate.com with any thoughts on the show, or to support me financially or otherwise some other way. And please, if you like what I'm doing, give the show a written review and a 5-star over at your podcast medium of choice. I know you hear this all the time from all them big podcasts. They don't need your love and support, I do. Makes a massive difference. And remember, on this show, we're all about learning stuff. And when you hear this noise, it denotes wisdom. Usually from my guest, not from me. You can check out the link in the show notes for more information about that thing. Right, on with it. In this chat with Helen Roberts, I find out all about how meteorologists model the weather and what climate change is doing to it, but also how they get that information across, or try to people. But before that, like the basics, how do weather forecasters forecast the weather? This all started for me when a few months ago I went to the Met Office where Helen works. I did a talk there, and beforehand Helen showed me around and I met people and saw clever things. I got a sense of the braininess of what it takes to model an entire planet's weather. But being a bit of a thickie, I thought I'd better go back to the start. So I indulged Helen's patience and I asked her to explain it all to me again from first principles. I do not have a very large brain when it comes to like computers and stuff like that. But when we were hanging out about a month ago and I was in the Met Office and you were showing me around and it was fab, you were explaining to me about how in practice it is done. So could you for a thickie audience, i.e. me, sort of explain like the sheer computing that goes on, what it is that's being computed and how the weather is predicted in practice?
Yeah, absolutely. So again, going back to that starting point of the observations, that's really key. So we need to know what's going on in the atmosphere at the moment. And that's on a global scale because of that interplay and interaction I mentioned. So how we tend to do it, again, there's always limited computing power and resources. So we tend to have a broad spectrum of observations around the globe, and then perhaps more detail, higher resolution. That's both in terms of observations and modelling across our particular part of the globe, so across and around the UK. So observations are the starting point. We receive literally billions a day when you think about all the different methods of observations that we're receiving. So we still use the traditional, I don't know if you've come across a Stevenson screen, but that's the white box on stilts, and you'll see them at airports sometimes, certainly RAF bases, occasionally randomly in fields around the UK. And they're really important pieces of equipment because they used to be made of wood, plastic these days, but they're slatted. So it allows air in and out, but mitigating the wind and any direct sunlight. So inside those, there will be a set of thermometers, a standard air temperature thermometer, also a wet bulb thermometer. So that gives us a level of humidity, and there will be often a maximum and minimum thermometer in there as well. So that will be read, those will be read on a daily basis to tell us the highs and the lows. As you can imagine, those sorts of pieces of equipment are increasingly being automised and replaced, but you still do see them and they're lovely. And then a whole host of other observations coming in from land and sea, remote sensing from satellite and radar systems. And those are all brought together and give us a current state of the atmosphere as a starting point for the numerical weather prediction that goes on inside the supercomputer. So at the Met Office and around the world, there are a whole host of incredibly intelligent modelers who use the science that our researchers are doing to incorporate into the numerical weather prediction. And so that's the physics of the atmosphere and mathematical equations. And actually, as far as I understand it, and this is not my area of expertise, but the equations are, to some extent, relatively simple. They're the equations of motion. They're the fundamental physics equations. And
I think the emphasis might be on the word relatively.
Well, yes, absolutely.
Yes.
And I'm not saying it's easy by any stretch of the imagination, but you can sort of write down the key equations that you used on one piece of paper, and that sort of broadly does the job. But of course, there's a huge amount more that goes into it than that. And so the atmosphere is then split into grid boxes. So you can sort of imagine, big cardboard box. Each corner of that box, there will be a point that's represented in the model. And so we know from the observations what is happening now at each of those corners. And then we run the model forward using the physics and maths to see what each of those grid points will be doing in the future. And those boxes go around the whole surface of the Earth and then are also stacked on top of each other through the depth of the atmosphere. Most of our weather happens in the lower part of the Earth's atmosphere, so the troposphere, but there's a little bit of interaction with lower parts of the stratosphere as well. So there are a few of those boxes stretch into the lower part of the stratosphere.
It's a miracle we can do it at all. I mean, you're describing basically building a whole as accurate as possible model of the Earth.
Yes.
Like ideally down to the atomic level, but we don't do that. And then running it forward, like that's an extraordinary thing for humans to be able to do, isn't it?
It is really extraordinary and interesting that you say for humans to be able to do, because the original concept for this way of predicting the future was a guy called Lewis Fry Richardson, and this was pre-computer days when humans were the computers. And he envisaged a scenario. So he was a conductor of an orchestra in a big auditorium, and the orchestra were the people computers, and they were the corners of the grid boxes, and they each had their own. At that point, it would have been fairly simple equations to compute. And he actually tried this. I don't think with an orchestra, but a version of this. And created, in effect, the first computational forecast. Unfortunately, it was wrong by a factor of 10, and it took longer to compute than it did for the weather to actually happen. So in that sense, it wasn't very useful. But I think it was a wonderful piece of, at least, wonderful piece of thinking. And in effect, it is how we create forecasts these days. It's just that with computers, we can do it much more quickly and more accurately. And so once you've got the data, then you've got your prediction for the future. And we have, as I briefly alluded to, we have different resolution models. So we have a slightly lower resolution around the whole globe, again, due to compute power. And then we have a higher resolution. So basically smaller boxes across the UK and the surrounding areas so that we can get greater detail. And that high resolution model is always improving, but at the moment for the UK, it's about 1.5 kilometres for each of those boxes. So that gives us the forecast and the data, and then it's about converting that into something that's useful for our customers and users. And that, of course, is very dependent on who you are and why you're interested in the weather. But for the general public, that might be a TV broadcast, or information on the web and app, and the weather warnings as well.
So there are lots of reasons I wanted to do an episode of Your Brain on Climate about meteorology, weather forecasting and that. One of them is that this thing called climate change is ultimately, in terms of how we experience it as humans, about changes in the weather. Climate is the name for the underlying conditions which define what we think normal is. And it's weather, like rain, heat, wind, all the rest of it, that's the stuff that causes the damage, what some people call climate impacts. When you walk out the door with the wrong clothes on, you're not feeling climate, you're feeling weather.
There is a difference between weather and climate. Obviously, they're very, very linked. There's a really great video that you can find on YouTube, and it's just a minute long. And it's a really good analogy, I think, for the difference between weather and climate. And it's a person walking their dog at sort of aerial view. So you're looking down from above and the dog's on a lead. Imagine they're sort of walking along a beach. And you track the path of the human, the dog walker, and you can sort of predict quite well, actually, where that person is going to be in the next few minutes, because unless something major happens, they're probably going to continue on the track that they're on. Whereas the dog on the lead is moving all around the place, and that's a good sort of analogy for weather. The weather will continue to be variable. And so we will continue to see some colder spells. It's just that there will be fewer of those as we move forwards.
Yeah, I like the analogy of someone walking up a hill with a yo-yo. So
nice, yes.
So the yo-yo is moving up the hill, but obviously in a kind of slightly chaotic, uppy-downy sort of way.
Yeah, that's a good one.
Now, the other reason I wanted to do an episode about meteorology is that telling people what the weather should be like tomorrow is a masterclass when you actually think about it in risk communication. Because as we found out, you can't really be sure about this stuff. They have to kind of give you the best information that they have, which is ultimately what a large part of climate communications is all about too. So if anyone knows about how to get people to understand complex, not 100% correct, but probably right information in a simple way, it's got to be them meteorologists. So what are the key principles then when you are telling people about the weather? What do you bear in mind when you're doing that? What's a good weather forecast doing?
Yeah, it's a really interesting question, because I think the answer to that has changed quite a lot since I started. So I joined as a trainee weather forecaster over 20 years ago. And at that point, it was made very clear to me that our job as weather forecasters was to create the forecast, yes, tailored somewhat to whoever our customer was, but to sort of hand it over, give it to them on a plate, and then it's up to them what they do with that forecast. And thankfully, that sort of process has changed a lot over the past couple of decades. And now we are much more, generally speaking, we're much more integrated with our customers. So what I mean by that is, as an example, we have operational meteorologists permanently on site at Heathrow in their operations centre. And that means that the meteorologists are not just handing over a forecast, but they are working with people to understand how the weather impacts their operations and try and help them with those decisions and those operations, both tactically and strategically. So thinking about the short-term weather hazards and the longer-term, for example, impacts of climate change on their operations, and bringing those services together as a much more holistic offering, I would say.
Good afternoon to you. Earlier on today, apparently a woman rang the BBC and said she heard that there was a hurricane on the way. Well, if you're watching, don't worry, there isn't. But having said that, actually, the weather will become very windy, but most of the strong winds...
When you're on if you are Michael Fish, or whoever the modern version of Michael Fish is, you've got 2 minutes to tell people whether it's going to rain on them or not. What do you try to impart in that time?
Yes. Yeah, limited time. I was a weather presenter for a while, so I know all about what it is it's really twofold. It's first of all what we often call the weather story, and this is something that we work really hard on to have a consistent weather story for the day or for the week. And our media services team, so meteorologists who specialise in media at the Met Office, will be giving, for example, regular briefings through the course of the day to our broadcast customers and partners to make sure that that message is consistent. So that's one key aspect of the forecast. What you really don't want is for someone to, watch a weather broadcast on BBC, turn over to ITV, and then have something completely different, because that's not very useful. So that consistency of message and that overall weather story, and the story will really be thinking about what are the key messages and what are the key impacts for people today? What do people care about? And we also have to remember broadcasting can be quite tricky, because you're inevitably talking to a large group of people, whether you're regional or a national presenter. It's still a fairly big geographical area, but actually the person who's listening is one individual person who's interested in what the weather will do over their head on that day. And they might be staying at home or they might be moving about. So there's all of those factors to consider. So inevitably, due to that and due to the time constraints, it has to be a little bit broad brush. But what you can do as a good communicator is, as I said, really pull out those key messages, the parts of the weather that are going to have the biggest impact on that person. And we know that the parts of the weather forecast that most people are interested in is, am I going to get wet today? I.e., do I need a brolly or a coat? And broadly, the temperature. But when I say the temperature, that's probably not necessarily a numerical value. Can be a bit tricky for me to think, okay, well, it's 18 degrees today. What does that actually mean? So by using comparisons and analogies, and an easy one is, will it be warmer or cooler than yesterday? How will it feel compared to yesterday? So that's quite a useful way of bringing it home to people.
That's awesome. And it's so interesting, isn't it? That you're trying to impart not what the weather's going to be, but how people should, well, they can do what they like, right? But your advice on kind of how they should behave or give it. So you're not actually trying to tell people the weather forecast is not take a brolly. The weather forecast is you should be advised that it's going to be a bit rainier than it was yesterday. And then if people take a brolly, that's up to them.
Exactly. Helping people make those decisions. That's what it's all about. When it comes to severe weather and weather warnings, we do actually use advice. And we have what we call advice statements, and people will maybe have seen these in the past couple of years when looking at warnings on the web and app. And it's a section called What Should I Do? And those advice statements have been developed using behavioural science, behavioural insights, fantastic piece of research that turned our warnings matrix. So our warnings are impact-based, and the matrix has the level of impact on the x-axis and the likelihood on the y-axis. And it's a sort of 16-box grid. What most people will see as a result of that is a colour of warning. So yellow, amber or red being the highest level, the most severe. By definition, it's high likelihood of high impact. But there are 4 different versions of amber warnings, depending on the level of impact and likelihood, 5 different versions of yellow warnings. And what that means is we know from our own research that most people, as I said, just use the colour to make a decision and don't dig into the matrix. And that's in part because we as the Met Office don't actively communicate it and promote it to the general public. It's there for people to see, but it's not the first thing you see. And it does take a bit of understanding. So the colour system is really great because, again, we know from research that it's pretty intuitive to most people, this traffic light system, yellow, amber, red. But the challenge is that with those different types of yellow and different types of amber, you might want to take different actions. A low likelihood of high impact, you might want to take different sort of mitigative action than a high likelihood of low impact. So what we've done is we've used this behavioural research to create advice that is bespoke to where on the matrix the warning is. And I think this is really fantastic. And and those advice statements have been there since December 2023, so not very long. Part of my research is to assess the efficacy of those. So do people actually take more action, more useful action as a result of this advice? But hopefully the answer is yes. And it means that we're really equipping people to prepare for especially safety of life scenarios and keep people safe in extreme and impactful weather, which, as we know, is increasing, becoming more frequent and more intense in our changing climate.
Your brain on climate.
As I record this, it's a couple of weeks before Christmas. The weather outside is supposed to be frightful. But today, in the middle of December, I was too hot walking about outside with a jumper on. The heating is not on. You don't need me to reel off all the ways in which our weather is changing. It's getting wilder, it's getting hotter, it's getting more menacing. It's climate change, mate. That's what it is. And the weather outside may not be frightful, but it is frightening. The weather is changing. Anyone who sticks their head out the window can see that. What would you say in the 20 years that you've been looking into the weather, forecasting it, presenting it, has been the changes?
So globally, we are pretty much all familiar with the fact that the temperature is rising on a global scale, and that is also true in the UK. So we've seen temperatures gradually increasing, and that means that we are seeing more intense and more frequent heat waves, for example. Heat waves are one of the most deadly weather types that we have. We've had 4 heat waves this summer. It's very interesting because I think people's perceptions of this summer, well, I would be interested to do some research and find out what people's perceptions of this summer are. But we know that perceptions don't always align with the data, the numerical values of what happened. And there are a whole host of reasons for that. But yes, heat waves becoming more frequent and more intense. But we're also seeing other types of extremes and changes in our weather in the UK. What we expect to happen over the coming decades, generally speaking, is warmer, wetter winters and hotter, drier summers. And we're starting to see that trend. Of course, that doesn't mean that we won't see cold snaps. There still will be some cold snaps, but those will become fewer and further between, and also perhaps less extreme. But situations like Beast from the East that we had back in 2018, I mean, that was in the midst.
I remember the Beast.
Remember that?
I remember
Yeah.
the Beast. Freezing it was. Snow. Great big
Yeah.
thick wads of snow everywhere.
Snow, ice, freezing rain, which is really very rare. So we can't rule those out. But what we do know, and we do have data to support, is that frost days are becoming much less frequent. Seasons are changing, and we can use the natural world and phenology, so looking at tree leaf and things like that, to demonstrate that the seasons are changing. An interesting thing that we measure is the grass growing and grass cutting season. So people are asked to log when they do their first mow and their last mow of the year or of the season. And when you average that out, that gives us a really good indication as to how the seasons are changing. So we're already seeing significant changes in seasons, in extreme weather, and that is going to continue.
So these days, whether you're a weather forecaster or not, you can't really talk about the weather and all the bonkers stuff going on with it without talking about climate change, not if you're paying attention anyway. And increasingly, here in the UK at least, Helen and her colleagues at the Met Office are doing just that. Now, climate change can sometimes feel abstract, but it's what's behind those storms that are increasingly ruining your fun, flooding your towns and messing up your barbecue. Getting that across when talking about the weather forecast, what it's going to do tomorrow, well, it feels like a way to bring climate change down to earth and make this sometimes fuzzy thing feel relevant to people's lives, right? But yet people don't pick up the weather forecast for a lecture about the bloody polar bears, and you've only got so much time to get across some really sharp information. So how do Helen and her colleagues approach talking about the climate when telling people about the weather?
The first thing to say is, and this isn't true everywhere, but at the Met Office, we use the same models for both weather and climate projection. So it's literally just running the weather models, but much further into the future for our climate projections. So in that way, that's really helpful because it gives us, we're using exactly the same physics and maths to do these projections, and we're getting the constant feedback from the weather. So we have good evidence that those climate projections are based in truth. So that's very useful. And in terms of messaging, I mean, actually, we conducted a survey a couple of years ago and found, I think from memory, that something like about 65% of people are aware that weather and climate are linked, which is quite a nice high number. But also when you flip that round, that means 35% of people are not aware of that link. So I think there's more we can do there in linking the two together, and we're working really hard on that. One of the things that we've been increasingly doing is using extreme weather events to talk about climate change and to put weather into a climate context. For example, on our press releases that we tend to issue routinely in the run-up to and following an extreme weather event, you will often find a paragraph or two in there putting that event into a climate change context. And again, developments in science have really helped us with that. So the science of climate attribution, where it used to be quite difficult for us to say with any confidence that this particular weather event has been influenced or impacted by climate change. And now we often can. And really helpfully, we can often do that on very short timescales. So we can run those attribution studies even sometimes in advance of an extreme weather scenario. So we can have that data ready to go. So you can imagine there's, a storm forecast to come through at the weekend. We can put out comms advising people what to do, what the expected impacts are, how you can keep yourself and your property safe, and use that communication to talk a little bit about climate change and say this type of storm has been made however many times more likely because of climate change, if that is the case.
That's really interesting. And that is a thing I've noticed changing in the broader communications around climate impacts is storm, whatever it was, will now be said, the Met Office said this is now 10 times more likely to have been, or whatever, because of climate change or whatever. Do you find that people take that in? What's the evidence show on whether people saying this is because of climate change is helping people think more that climate change is real and scary?
Yeah, it's something we don't have a definitive answer to yet, and it's something we are working on. We're running a study at the moment to try and better understand that. One of our concerns, and it would be interesting to hear your views on this actually, is that there is a potential if we do this every single time, every time there's an extreme weather event, we talk about climate change, is there the potential that we're putting people off, that people are sick of hearing about climate change or feeling like we're, forcing this message on them? So that's why we're doing this piece of research, to see if it might be that there is an optimum level rather than just doing it every single time.
Yeah, it is tricky, isn't it? Because one of the biggest problems with climate change stuff is it just becomes normalised. The climate is changing, but already someone who's 18 years old now doesn't really know it any different than it gets over 30 degrees in the summer all the time. And similarly, like if every time there's a storm, someone goes on the telly and goes, this is because of climate change, after a while that is going to lose its impact, I would have thought.
Yeah.
And I think from a risk communication point of view, it's fascinating. Like, how and when do you sound that alarm? Also, I mean, there's loads of stuff, as you all know, that after a storm, people generally want life to go back to normal. They don't want to think about the fact it might happen again, right?
Yes. Yeah. And there's a lot of evidence to suggest sort of moving a little bit into the psychology now. And I'm really interested in heuristics and cognitive biases and understanding those to help us with more effective communication. So we do know from research that people who have recent experience of their property being flooded, for example, are then more likely to take mitigative action when there is a warning of further flooding. That makes perfect sense. I mean, that's fairly intuitive. But what that means is that people who haven't had that experience are less likely to take action. And so we need to focus on those people. And actually, even there's a sort of drop-off point of around about a decade. So if it's more than a decade ago that you've experienced that flooding, it's sort of phased from the memory. And again, you're less likely to take action. So I think what that's telling us is that the reason people with that recent experience is sort of this availability bias, this salience. It's strong in the memory. It was a horrible event that happened, and I don't want that to happen again. So we need to make it as salient and tangible and real for people who haven't had that direct experience as possible. And so we're thinking about ways in which we might be able to do that. And you can imagine that perhaps the use of imagery could be really useful there. Rather than just telling people, maybe we can show people, and that could help people to understand how that really might impact me in my home.
Yeah, and I was going to ask you anyway about imagery, because it happens a lot less, but I've noticed it does still happen that when there is a massive heat wave going on, which is endangering life and limb, you still get illustrations of what that looks like with someone sitting on the beach eating an ice cream. And I'm wondering if there is there a conscious effort to try to change that in the weather community?
For sure. Yes, absolutely. It's lovely to celebrate the positive aspects of the weather. And, it's really great to be able to go and eat an ice cream on the beach in the warm sunshine. But when that becomes really unhelpful is when the impacts are going to be dangerous, and that type of imagery can really it negatively impacts our ability to warn people of the dangers of heat. And heat is a really interesting one. Of the 8 types of weather hazards that we warn for through our National Severe Weather Warning Service, heat is really quite different to the others because of that thing you mentioned of many people enjoy the heat, and it's really difficult, again, because of the difficulty of making the dangerous aspect of heat really salient and tangible to people. There's a fantastic resource by called Climate Visuals by Climate Outreach, I think, which is a whole host of free-to-use imagery, and they're trying to do exactly that. They're using they've got photos of people who are, struggling in the heat, or crops that are failing in the heat, and these sorts of things that hopefully bring it home to people a little bit more. And the other interesting thing about heat in comparison with other weather hazards is that we often talk about vulnerable people or vulnerable populations, and often in other weather hazards, vulnerable people might be people who don't have the ability to get around, or don't have the ability to keep their property safe. Might be people with existing health conditions, and the elderly and the young. That is true with heat, but there are also other people who become vulnerable to heat who wouldn't, in other circumstances, consider themselves vulnerable. People like construction workers who are working outside in the midday sun, people like athletes who are training outside. These people are not people we traditionally consider in vulnerable groups, but they become vulnerable to the impacts of extreme heat. So that's something else that we're thinking about and working on. And those sorts of visuals can be really helpful. Showing a construction worker outside really struggling with the midday heat.
Mm-hmm. Yeah, I've been reading some fascinating stuff. I've had a couple of episodes recently about heat and kind of what that does to people. Some fascinating stuff about school tests when when there's a summer when it's really hot, kids do less well in their exams.
Yes.
Crudely.
Yes. And you were talking about the links with crime as well. It was a fascinating episode. And something I find really, really interesting. More to do with mood, but that then can lead on to different types of crime being associated with different types of weather, and certainly in heat. And interestingly, particularly in humidity and in humid heat, people's levels of aggression go up. There's more opportunity for that sort of interpersonal crime and opportunistic crime because people are congregating, there might be alcohol involved. And also with people congregating, there's also properties empty. So there's all those sorts of crimes that tend to rise.
October 8th, 2024, day before Milton is supposed to hit, heading north to Panama City Beach. Look at what they're doing. They're trailing freaking crap out of us. Look at this.
So this is a clip from a video that was shared on social media the day before Hurricane Milton made landfall in Florida in 2024. It's someone pointing a camera at the sky, pointing out that the day before the hurricane was due to strike, in their opinion, the government had been up there geoengineering the weather, putting chemtrails up there to make the hurricane more deadly, to control more people. Now, obviously, this is correct because chemtrails are totally real, and the Biden administration, who was in charge at the time, absolutely definitely had the ability to make a hurricane happen, despite its, apparent inability to make much else happen on purpose. I mean, we learned at the start of this episode that butterflies can cause hurricanes by mistake, so why can't the US government do it on purpose? Obviously bollocks, but there are some people who genuinely do seem to think that the weather is a deliberate plot that's being controlled, that is out to get them. People with influence, like here is an actual quote from an actual Congresswoman, Marjorie Taylor Greene, from the same year.
Yes, they can control the weather. It's ridiculous for anyone to lie and say it can't be done.
Now, I'm sure American listeners are rolling their eyes at that, and I think she might be considered an outlier. But this stuff has consequences, right? We all get annoyed when the weather forecast says it's not going to rain, and then it does. But some people are a different level. Around the time of Hurricane Milton, thanks to nonsense like that we just heard, US weather forecasters got death threats for saying there would be a hurricane, which, they would. They were just saying that. Now, it would understandably stress you out, and that's not why you get into weather forecasting, to wind people up. But that's not the only distressing thing, is it, about spending all day as a meteorologist looking down the barrel of what climate change is doing and has in store for our beautiful planet. So can I ask, and I understand this is a hard thing to talk about, but you and colleagues spend all day looking down the barrel of seriously scary data about what's happening, what's in store. And I wonder how you deal with that in a work context. How do you and your colleagues hold it all together and, get on with stuff? Yeah,
it's a challenge. It's really hard. You're absolutely right. We're absolutely immersed in this scary data all day, every day. Some colleagues, in particular, some of our climate scientists really have struggled with that. I mean, we all do on occasion, don't we? But yes, due to the nature of their work, it's particularly salient for them. We have we have lots of resources to help people. And we did have a really fantastic climate change and mental health week, for example, at the Met Office a couple of years ago. And hopefully we'll do something similar again. So it provided the opportunity to learn about others, to talk about our own experiences, and for people to offer, more formal support in that context as well. And that's really important because, the last thing we want in the climate crisis is to burn out all of our climate scientists. So it's really, really crucial that we look after people. And that's also true, actually, of people working in the more immediate timescales of weather forecasting and weather information. There's been a really sad increase in sort of online trolling, for example, of weather forecasters, weather presenters in recent years. So again, making sure that we support everyone and that we have the resources available for people to be able to manage that and keep themselves away from that where possible.
Well, so people will have a go personally at weather forecasters because what? Because they are saying it's getting hotter because of climate change, or they're just saying it's going to rain and I don't want it to rain, or what?
Both of those things. From my own personal experience, and I have to say I'm really grateful that I haven't had any significant negative impacts at all. But just as something I've noticed is that any mention from me or in a post that has my name in it, as soon as you use the word climate or climate change, it does seem to draw out these people who just want to jump on the bandwagon and have a go. And it seems that it doesn't really matter to them what the exact message is. It's just about having that voice to be able to have a rant. And that can get very personal and that's not fair.
And for you, what keeps you carrying on and doing this stuff? What's your motivation for it all?
My motivation is that I love what I do. I'm really passionate about it. I enjoy coming to work every day, and that's because I have a real sense of purpose in my job. I can see the direct impact of the work that I'm doing, and particularly around weather warnings and that whole weather warning system. If I can think that maybe I've saved a life, or I've saved someone from property flooding, and the absolute enormity of those sorts of scenarios, then how brilliant is that? How lucky am I to be able to think that I might be helping people?
It's making me think a bit about I'm going to do one of my clunky analogies now, which this podcast's all about. You were talking about butterfly effects and people, a butterfly in the Amazon flaps its wings and it rains in Cambridge on Tuesday. But in a way, that's kind of what we're all doing as well. Like, it can sometimes seem like everything's too bad and there's nothing you can do about it. But kind of anything you do somewhere might ripple out and lead to a massive change somewhere else.
I think that's a brilliant way of thinking about it and bringing those two worlds together. Absolutely. None of us can solve the climate crisis on our own, but we can all do our part. And those small things all add up to a much bigger change. And that's just wonderful.
Thanks so much for listening to this episode of Your Brain on Climate with me, Dave. A huge thanks to Helen Roberts, socio-meteorologist extraordinaire, for giving up her time to talk to me. A massive thanks to the fabulous Ruth Everett for the voices, and to my friend Professor Adam Harris, him off the confirmation bias episode, for a bit of background help with the research. If you like this, check out that back catalogue. There's plenty in there to go around. Please do share this episode with a friend and drop me a review on your podcast medium of choice. It makes a huge difference to a little old indie podcaster in a sea of big, rich companies. And you might even consider chucking in the price of a cup of tea to support the running costs of this esteemed organ over at patreon.com/yourbrainonclimate. It's Christmas. Give me a little thank you. All right, I'll be back soon. If you're listening to this round about the time it comes out, I wish you and everyone that you love all the best for for Christmas, or however you celebrate. And whatever the weather this time of year, snow, slush, mud, rain, or even unseasonal heatwave, please take care of yourself, and I'll speak to you again very soon. Okay, bye.